Hey guys, I'm Christopher Glyer.
And I'm Nick Carr.
And this is Season 2 of Stay the Hack. And today we're going to get into it real quick. We've got
a lot of stuff to talk about.
So we're going to start with Threat Activity Roundup. Posted a poll on Twitter last night to hear what you guys want to talk about. It was a pretty resounding answer. You didn't want to hear about React attacks recently because I got no votes for that. So
we chatted a bit about that last episode and put out a blog about that. So if you want that, there it is.
Yeah. All right. So the things you did want to hear about were Deeann Espionage and some of the APT3 attacks that we've seen with
the APT33.
Yep.
Yes, so since we last had our episode in Christmas sweaters, today we got, I guess, hacker hoodies, a little more casual, growing out the beard. I noticed you didn't shave either, so a little bit. We're going to talk about, let's hit up front some of the activity that is aligned with, potentially with APT33. We put out the blog post called Overruled. Put it out at the end of last year.
It was like one of the longer blog posts we put out in a while, I think.
Yes. So it's kind of cool because between that and the previous APT29 post, we're trying to talk about getting to the technical details of some of the unknowns and start sharing that activity earlier before we've reached all of our final conclusions. But that was kind of a neat story, how we it started with our 24/7 managed defense team, the SOC for the world that we have, and these guys stopped a few intrusions, and we didn't know a lot about it. And frankly, from their perspective, a lot of guys probably it was closing out alerts.
It was a Tuesday for them, right?
Like, a little bit of investigation and moving on. And we wanted to take the time to pull that together because there was a lot of indication as we looked at the larger story that those attackers were actually aligned with APT33, the guys that likely deployed Shamoon. And so the blog post explores that, and what I was hoping people would get out of it, what we're trying to share with the public and get our teams excited about, and SOCs all over the place, is like the things you're investigating, the things you're looking up might lead to some of these other attacks, and no one really talks about the things that are stopped. They only talk about the things that were successful. And so we also use the opportunity to talk about Ruler, and specifically Ruler homepage persistence. So Sense Post's Ruler tool, I don't know if you had seen it a lot, but we've certainly noticed an uptick.
Yeah, and we've definitely talked about it on multiple different shows, but we tried to kind of walk through some of the technical details in the blog and some of what it means. One thing, if you're doing an investigation and say you see Outlook spawning command.exe or PowerShell or something else, you shouldn't just assume that was a spear phishing attack, because in this case, if someone uses Ruler or something else, it could be that they either got or guessed or credential stuffed or something accounts to a user and then used homepage persistence to run code on that user's box.
Right. So same with the multiple modules of Ruler and all the different ways you could use, exploit the Outlook client to launch those commands. So we see that a lot there. We try to be pretty explicit in the blog, suggesting, hey, this often is misinterpreted as a phishing email because it starts with Outlook, but if you think that's the case, you make fundamental mistakes, like you don't know that in order to use this, they already had valid credentials.
Right, which means you have a bigger problem that, from a remediation or investigative perspective, that, how did they get those credentials? Did they guess them? Do they have other users' credentials?
Yep.
Right.
And people get into putting mitigations in the wrong place, like email security stuff, which is helpful and necessary, and I really recommend it, but they have single-factor credentials.
Right, or wipe the box and move on, even if it had malware. Like, great, okay, well, I've remediated that. Well, actually haven't, because they can just do the same thing to the user's next box, right?
Yes. So if you get a chance, definitely check out that blog if you didn't have the opportunity to. And one little side note, Doug Beanstalk, who does we talked about him previously with this Ponoth tool. He spoke at ShmooCon recently about O365 security. He noted that the patch for homepage persistence is actually pretty brittle and can be rolled back in the registry, so recommends that there's not a real permanent fix that's in place for homepage persistence.
Well, it's a client-side patch on a server-side patch too.
Yes.
Right?
Yeah, so you have the issue with people that have maybe Office 365 and think that because that's secured for them, they don't need to worry about the client that's actually accessing it, which is the core of the issue. And then the client patch here is pretty brittle, and there's a number of ways to roll it back. So we expect we'll keep seeing this used in the wild.
Yep. I mean, no hasn't stopped anybody using it, even though the patch has been out for a while. It's a super popular technique across multiple groups.
So speaking of mitigations that are hard,
yeah.
Deeann Espionage.
Yeah. So this one, so we released a blog as a follow-up to Talos, a blog they put out in November, and we kind of highlighted three different, a range of different threat actors that we believe have Iranian nexus, and there were three different kind of techniques that they were using, either as a means to break into a victim or to facilitate an intrusion into a victim. So the basic attack goes that you would break into, say, the registrar, and in the registrar you would then update the A record or an NS record, and you may use that with, say, a DNS Redirector, which is the third type of attack. And the key here is you're actually updating the DNS record, say, for mail.victim.com, to point to the attacker's infrastructure. So now every, say Outlook client or Thunderbird or whatever you use, say, your browser with Outlook Web Access, it's going to then get the IP address of the attacker's C2 server. They would also then register, say, a new certificate, and they use multiple different certificate providers, but say Let's Encrypt, with the actual like mail.victim.com in the certificate. And the reason they could do that is because once you own DNS, that's all the validation that the certificate providers can do is make sure that you own the DNS infrastructure, which you do. So they have now, say, a Let's Encrypt certificate is the example used in the blog. There are other providers that were used. And I now get your traffic from your Outlook client to flow through me when it goes to mail.outlook.com, command in the middle of the traffic, and then get clear text visibility to, say, your creds. Or if I do it to your VPN, say your vpn.victim.com, I can now get it for your VPN creds, and or any multi-factor authentication you have is now flowing through me that's going to that particular location. So I can harvest usernames, I can harvest credentials, potentially multi-factor, and or anything else going over that particular channel. So
yeah, it's pretty bad, hard to detect at scale, specifically hard to put out, IOCs, because you just have impacted victims if they're compromising at the registrar.
Right.
So I think we had some indication that it was a pretty widespread campaign, and Mux Harani, who was one of the authors of the blog, talked about how widespread we felt it was. That seems to be resounding. Just recently, DHS actually
even put like an emergency order.
Yeah, they had some new, since they reorganized under CISA, I think it's one of their first requirements where they force people's hand to do something. I'm not sure how effective it'll be, again,
10
because
days.
of the shutdown.
Right.
But 10 days for people to secure their DNS infrastructure to these.
10 days for the furloughed workers to
yeah.
not do it, right?
Yes. So, anyways, it's been interesting to see those campaigns continue. We're still tracking all of that activity, and we'll keep people updated. Definitely check out those blogs.
Yeah. So some of the challenges from a defender's perspective, if this were to happen to you, or if you were to even try and figure out, is this happening to me? It's really hard because there's really a lack of evidence, right? You'd have to look at the logs of, say, what IP addresses are accessing my mail server, right? And you'd have to notice or find that I was getting all sorts of different IPs accessing my mail server, and all of a sudden now I'm only getting one IP, and that one IP is at, say, a VPS provider, anywhere in the world, right? Or a hosting provider, and that is the type of technical analysis that is very difficult for organizations to do, at least in my experience.
Yep. And web services forensic stuff is difficult based on my experience running that stuff down. I'd categorize domain registrars probably in the same category. Obviously, hopefully most people aren't necessarily using individual places like GoDaddy maybe under individual user's account, but for mine, if I went in to try to pull and get any information about who's logged into it, if I'm not using two-factor,
yep,
there's not going to be a lot there. They're not built to provide people that information.
Well, and the other thing is, if you look, say, from a forensic perspective, you're like, okay, well, I want to search my endpoint EDR tool to find all instances of Outlook connecting to an IP address that's at a VPS provider, even if you had, like, say, the list of, net blocks. Even that, A, is super noisy because it happens more than you'd think, and B, you'd almost have to do, a lot of times in forensics we look for, least frequency of occurrence. You'd actually have to look for, most frequency of occurrence, because it wouldn't happen in just one system. You'd want, all of your systems would have to be doing it at the same time. It's a really difficult, it's a crafty attack. If you can pull it off, incredibly successful. and most victims would probably have no idea that it even happened to them.
Ooh, I like that as a transition into our guest for crafty attacks and most victims not being able to do much about it. Let's bring in our special guest today, Matt Dunwoody. Welcome.
Cheers.
Thanks for having me.
Thanks for bringing the beer. What are we drinking, by the way?
So this is 0 Day. This is the official beer BrewCon. So that was one of the conferences that we were actually able to present the No Easy Breach, and then this year went back and did the Signatures Are Dead detection talk with Daniel Bohannon, and so this was actually part of the speaker gift. So
yeah,
nice.
To backstory, Matt is probably one of the foremost experts here at FireEye in terms of doing intrusions of APT29, and especially in the heyday of the 2014, 15, 16 timeframe, led many of the most bigger and complicated ones. And
yeah, we find ourselves referring back to #NoEasyBreach a good amount when we're talking about techniques, especially techniques that are moving downstream. Groups like APT32 that use a lot of these, and a lot of red team tradecraft, a lot of cool stuff that's developed out. We find ourselves referencing what we experienced in 2014 a lot. As we've provided a history of methods on the show too, there's a couple reasons we thought we wanted to deep dive APT29 with Dunwoody today. The first, obviously, like last episode, we talked about the suspected reemergence of APT29 in November 2018, and some of that campaign, and frankly, some of why people might have underestimated their capabilities based on that campaign. That had us a little bit worried, and then we lead into, we just got over ShmooCon. I know you were at ShmooCon again. Doug spoke there. That marked our 3-year anniversary this year of when we first talked about No Easy Breach. That was the first time we talked publicly about the 2014 activity, and of course the DNC complaint, the amended DNC civil complaint,
where they added the recent APT29 phishing attack details that we first talked about to that civil complaint as well.
Yes. So there's a lot of reasons to talk about them, and also it's an excellent reason to have Dunwoody on to talk about it. He's written a number of blogs that we'll try to link to for it, but we just really wanted to focus on getting back to 2014 and talk about the number of firsts that we saw then. And we're hoping that as we highlight it at that level, it will be impactful to people who are using a lot of this tradecraft today.
Or with ideas of how you might look for similar tradecraft, because a number of the techniques we're going to talk about, some of them are public and people have started to pick up, and then others still aren't public. And so thinking through how you might, as a defender, deal with some of this more advanced tradecraft.
Yes.
It's really a testament to that 5 years later people are still using this and it's still relevant, and a lot of it's still not even being detected.
So set the stage for us, like No Easy Breach, like
Yeah, so if you get a chance to check out No Easy Breach, our DerbyCon 2016 recording seems to be the most straightforward on it.
Yeah, there's also ShmooCon 2016, but the audio isn't the greatest.
Yeah.
And we have Dunwoody has the slides up on SlideShare, so you can check it out there. That we gave the perspective there of a specific victim, like 1,000 compromised systems, 1,000 unique malware samples, over 1,000 unique compromised domains and IPs used for infrastructure. Most of those each set up one per system, like a 1-for-1 with the malware. And then I think when you said with tools and scripts, you counted up how much just malicious stuff we collected, and it was
thousands of samples.
Yeah, so I think 7,000. So tons and tons of emails taken, all kinds of stuff. So we really deep dive that one client there. Definitely check it out. We want to bring it up high level and explain tradecraft wise what was so new about each piece that they were doing. So yeah, that was, to me, a lot got overlooked, and we probably should have blogged more directly on some of these things we saw while we were seeing them.
Right.
So we don't do a lot of, hey, we saw that, but this is our opportunity to catch up and do that. And through the process, we'll probably share a bunch of new stuff we haven't previously shared.
Yeah, there was so much that even when we were trying to go through and do the talk, there was just a lot that ended up on the cutting room floor. It just couldn't fit.
Yes. So I mean, we can open it up. I'm curious. Some of it sounds maybe a little different now, but we can start with some of the WMI activity. I know we talked about that, but I know WMI was a big piece of your research.
Right.
They weren't the first group to use WMI, but they were the first group we saw use WMI in the particular way that they did.
Yeah, so APT 40, so Temp Periscope is actually the first group we saw use it a little earlier in 2014, and that's actually, that initial research then enabled us then to figure out, even to look for it in these particular cases in later in 2014. So they weren't the first, they were actually probably the second from our perspective, but how their use of WMI was very different. So APT40 used an MOF file to basically get the content into the SIM repository to execute what they wanted. And APT29 kind of took that to another level where they were actually then using, they created like either their own class and actually put the entire script inside the SIM repository. So there was basically nothing on disk at all. That was probably the most crafty way that they used it. But there are a bunch of different kind of creative ways they used WMI that was, I thought, unique.
Yeah, I mean, WMI for persistence, for lateral movement, for like fileless data storage. They use it for a lot of things. And I mean, and even kind of combining those, we saw like that a tool that used WMI to actually run invoke BBcats on remote systems. So they would write that into the SIM repo on the remote system and then send the process create call to actually run the contents of the repo in memory and then write the credentials into the repo, read that all out, and then delete all of it. And so, you know, from a forensics perspective, you'll see like some authentication events, and you'll see like PowerShell getting run by WMI PRVSE for the execution, but it just didn't leave a lot on the box.
Right. Because it's all inside the SIMv2 repository, which
is like its own little file system.
Right. Which isn't really very well documented. And going through the research and everything else, it was like this, like something that has been there since like Windows 2000, but has been kind of like forgotten about. And so somebody else did a bunch of research and was like, ooh, we can use this in kind of a creative way. Absolutely.
And actually, because of that, we now have the Flare WMI tool that will actually parse all that repo. And we even put in there the capability to grab slack space out of there. So when you delete stuff in the SIM repo, it doesn't actually, like it gets like deallocated, but not really deleted. And so we actually do have a tool now that we can pull that data out. And so that's really useful if you have an attacker doing something crafty like that.
For some of the, like, and you've spoken about the encrypted backdoors that was basically stored on a remote system in the WMI repo, and like wasn't there specific controls around when that would compile, like set for the compiling in the future?
Yeah. So I did write a blog on a backdoor that we call PushSpy, and so basically it would have the data written into the SIM repository, encrypted, and then they would have basically a persistence element in there that would run on certain days of the week at certain times, and each time we saw was configured a little bit differently. But you know, so it might be Tuesday, Wednesday, Thursday, Friday at 12:35 it's going to beacon out, and then it would basically go in, decrypt the contents of that script out of the repo, execute it in memory, and then basically it used a domain generation algorithm that used only legitimate compromised domains. And actually those were specifically for organizations that were geographically located near the target. And then was able to use that as its C2 mechanism. So basically would just beacon every now and then to something that looked completely legitimate.
I think we'll get a little bit more into some of how that worked as well. And when we say 1,000 compromised domains and IPs that they used, to me that's one of the most fascinating cases, because the infrastructure used there, they compromised and they maintained, right? And they reused it, and that's some of how we tied them together.
And it wasn't like a mom and pop shop, right? It was another large organization that is well known. So, from a defender's perspective on the WMI side, things that, like how would you find it if someone was using WMI maliciously? You could use, say, PowerShell if you want to query all your systems and get all the command line event consumers or the active script event consumers, and then basically stack that data and see like what's common in your environment, what's not, what's it pointing to. That's something that, like, that frequency of occurrence stuff, because they're not used that commonly legitimately. So like once you know to look for it, doing that at scale actually works pretty well.
Yeah, there's only a couple of things we've seen, which was basically like LoJack software using it. That sort of thing where it's.
And then there's the one that's on everyone, which is like the BVT consumer.
Yeah, which doesn't actually do anything, which is fun.
So we also, this is the first time at least that I had seen a golden ticket attack and didn't quite know what it was. Spent a lot of time on adsecurity.org, on Sean Metcalf's site, trying to understand some of it. So I know we talk about that in great detail during No Easy Breach, but it was pretty cool to see that for the first time.
When we found the .krb file, right? So you're like, okay, so I see an actual like Kerberos file here that they're using to authenticate systems, but that was, Benjamin Delpy had already put it in Mimikatz, so it wasn't that they necessarily developed the technique, but it was the first time that we've seen an attacker actually use the technique.
It was the first time we had to, as defenders, come up with ways to analyze .krb files, but also analyze what you could detect on, and that changed, right?
It did. So yeah, at the time there was basically Mimikatz was correctly implementing Kerberos, and Windows wasn't. And so then we were able to identify that inconsistency. Since then, Windows has updated it to actually correctly implement Kerberos, and Mimikatz has been updated a couple of different times to make it a little bit more evasive. So now, from like a logging perspective, it all blends in really well. But you know, that was an interesting challenge and very consistent with a lot of the other things we saw. So we didn't see them reusing like C2. We didn't see them reusing file hashes, any of that stuff. We didn't really see them reuse accounts either, because they could just invent accounts for every time they wanted to log into somewhere. So that was another challenge where it was an indicator we typically would use a lot was just gone.
Other interesting techniques, and we referenced it in our 2019 prediction episode in November with Steve Booth, as a trend we continue to see now is like multi-platform scripting language-based backdoors, like Go backdoors and stuff like that. Notably, back in 2014,
first, right?
They were rolling with the Python backdoor. Why do you think that was?
Yeah, I mean, cross-platform's great, and at the same time, they were also updating these. I mean, we saw them go through, what, 3 or 4 different versions of that one backdoor. So, I mean, this is CDaddy, right? It's also called CDuke.
Yep.
Made workhorse backdoor for literally years. And yeah, I mean, they kind of keep building in new functionality to it. We saw them iterate through a lot of those. So really easy to update, really easy to deploy, really easy to change in order to kind of change your file hashes and things like that. And also kind of evasive. You know, anytime you have these like PyDXE, PyInstaller backdoors, they can be a little bit annoying to detect reliably.
Right, so just using the underlying script language, there's all these other ways to package it up. And PyInstaller, PyDXE, and then UPX pack them.
Yeah.
And those decisions, of course, have forensic artifacts they leave, which we talked about.
Right.
No, that's pretty cool. I know on the network side, that was one of the first times, too, as defenders, we used TLS fingerprinting to identify activity. And that's become more popular with JA3 with the Salesforce team. But we did that during this response.
You were ahead of your time.
Yeah.
Yeah, it's definitely a lot more formalized now, but we were able to make it work. Yeah.
You did like the janky version
with the with Bro's SSL log. If people have that layer 7 metadata stuff, there's not as many fields, but a couple things and commonalities in the certificates that you can link together and the cipher type. So it was pretty neat seeing that. And fast forward to now, we see that as being super valuable and a big piece of how we categorize traffic as defenders. So yet another, you know, first as it relates to these guys that's still going on today.
And the cross-platform malware, like what's great about it is they can, you know, they wrote it in a way, I mean, we could clearly see, like if you look at like decompiled to Python, you can actually see that there's like specific hooks to be like, if Windows do blah, if, you know, looking for different types and what it's going to run. But now you can like write once and, yeah, you have to recompile it, but at least run anywhere. They're not the first group that we've ever seen deploy like non-Windows specific stuff. Like I know we've seen different like Chinese APT groups use like photo backdoors and like Linux servers, but those weren't necessarily cross-platform like written to begin with. They just had a Linux implementation.
One of the cool parts is at the rate that they were compromising new systems with unique compromised C2, perhaps having like a Python-based backdoor lets the operator actually customize it and doesn't have to be a totally separate build team. You can just point it to your new infrastructure and roll there with a script-based backdoor.
Yeah, it definitely seemed like they probably had a builder or something, because they were like putting out so many of those new versions, so many new individual samples.
Yeah, so I think one of the more notable things was, at least like from the presentation, obviously the IR, was that like at one point during the investigation, they were just trying to like outrun the investigation team. Like, you guys want to walk through a little bit, kind of, I don't know, kind of what that felt like, or what you were experiencing with that, because that's not it's not a super common trend that we see. I mean, obviously we see attackers try and like maybe like do that once, but not like on a daily basis for like weeks and months.
Yeah, so I mean, after that initial remediation attempt that wasn't successful prior to like our heavy involvement, the attacker, just went nuts. They that main CDADI backdoor, they deploy that to a dozen systems a day, anywhere between 10 and 15. They configure some of them a little bit differently than others, and kind of watch what we were doing, watch which systems were getting pulled offline, things like that. And then they really used a lot of that noise to kind of cover some of their more discrete activities. So whenever they did data theft, they would access the system, use that to do data theft, and then just burn that down and never touch that system again. So there were so many systems that they were touching throughout this process, whether it was just kind of for noise, whether for persistence, some of their deeper persistence where they were putting in, some of these more interesting backdoors we found, things like the domain fronting backdoor that maybe we'll talk about a little bit more, or hammer toss, one of the ones that, I still see references to hammer toss routinely on Twitter. And it's amazing to think that, we found this backdoor 5 years ago and it's still influencing tool development and even thinking today. So using that kind of OPSEC where you use your own noise to hide in is something that I don't think we've really seen anywhere else, and is a really interesting and kind of unique perspective for this group.
Everything was so layered. So not only would there be noise that they generate each day and the 10 systems you have to run down and then one they would operate on, but I think you just mentioned they wouldn't, even if we didn't find them before we were really excellent at finding them, every 2 or 3 days they would just pack up and move. And so you'd respond and you'd look at the system and you're like,
with their pattern behavior, and then be like, all right,
they wouldn't remain, they don't maintain their foothold. They would pack it up and move that foothold somewhere else. And that was what was, they just had a crazy understanding, I think, of the defender perspective, maybe because they were also targeting the IR team, but
that's
sure.
True. Yeah, and that does kind of segue us into the next thing, which is actually targeting the response efforts in a concerted way to actually monitor the email and communications of both the security team and the IT teams that would be involved, and really leveraging that data to their benefit.
So that was the end goal, right? Was targeting VIP emails, targeting intel specifically from individuals, but they would also roll up the security team and device alerts and everything like that. Yeah. So how are they accessing email like that?
Yeah, so we've seen them access email in a number of different ways. In this particular organization, they were using Exchange Web Services. So they had a custom script that just wrapped the EWS DLL, and so then just made legitimate connections into EWS. It was all encrypted. It was all very legitimate looking, but at the same time, they were able to pull down email for anyone they wanted. It was a really nice full-feature tool, too. You could specify, did you want the inbox or the sent files, give a date range, everything you could possibly want for mass consistent email data theft.
And so that was definitely a first for us with using that Exchange admin account with the flexibility.
It wasn't the first time we saw email harvesting.
Right.
Because APT1 and everybody else has done it for a long time. But specifically using the EWS API with the Exchange.
To come back and feel it was supporting espionage, right? They would take off. There was a Russian holiday, as it turned out, and they came back after that and gave it, attack 5 to get the last 5 days as opposed to the last 3 days over that weekend. And I remember seeing that, but you just actually really thinking oh man, at the rate they're taking it, perhaps they're even analyzing it at this rate. And the flexibility, the documentation in the tool, the debugging was really nice.
Yeah. Oh yeah, all of their scripts, all of their tools, really well written, nice output, cleanly formatted.
And so all these scripts were in addition to the 7 total new backdoor families introduced during the intrusion. I guess 5 or so new ones.
5 new, and then 2 that we
we keep seeing. And then all these other helper tools that we don't roll those into it. So
one of the frustrating things from a defender's perspective was, especially with one of the backdoors, we could have the full PCAP of the backdoor and the malware itself, and we couldn't actually decrypt or decode the traffic. So then trying to turn that back into their original commands, which is what we've done now for a long time with our network sensors. We couldn't do here. And how they did it was I think particularly unique.
Yeah, when it comes to so back to CDADI, underneath the SSL connections, as it were, eventually they were using their communication that used RC4 and AES, and the specific RC4 key they just generated and never shared. So what you're referring to is within the PCAP, they actually don't pre-share that key anywhere, and so our thought was that they were likely just. The reason they picked only a 7-character RC4 key was that on their side they were brute forcing the comms, and we believe that because we were able to do it just with really poor computing power as responders, but because it's RC4 and it returns JSON, you just had to basically look for a bracket, and you're able to do that in the first block. But we couldn't figure out any other way that it was being shared back, and it's feasible that they were basically just literally within it, randomly generating it, not sharing back, and then on their end they would just brute force.
Yeah, and that was like generation 4 or 5 of that backdoor. So we used to be able to decode all of it, and then it got harder, and it got harder, and then we just couldn't.
The worst.
Yep.
Or the best.
Depending on how you look at it.
I still haven't seen another group use that technique. That's still like kind of first and only to them.
Yep.
Yeah.
I don't know if you guys have, but that's something I'm aware of.
Yeah. I mean, another good technique, we touched on hammer toss briefly, but I mean, the way that they deployed that, the backdoor itself is amazing, and we have a really good report out there on it that you can just pull up off of our blog. This tiny little .NET backdoor, super flexible. But the way that they deployed it, overwriting like the legitimate Windows Error Reporting Manager, using the existing persistence for that so you can't see it, and they were actually double time stomping those as well, and padding the file out to the right size, and replacing the version information on it. Like, they were so thorough with that. It was really hard to actually nail that down.
So we said, like, I think they used 7 different persistence mechanisms just for their one backdoor that they would rotate through. What's so hard with the persistence is, like, you kind of only know after deep diving on a system how something is persistent. I remember this with like Fin7 and some of our guys that were responding to find the shimdb persistence stuff, and you only really you have to lead to figuring out, okay, how is this persistent? And like, so we found 7 different methods. They were overriding scheduled tasks. APT29 was the first I saw that actually like stomped existing scheduled tasks using the XML, the task XML, and running that.
Instead of like scheduling a new one, for example.
Right, or using a SCH task to change it.
This stuff moved downstream, leveraging existing tasks by overwriting Adobe and stuff like that. That's where we saw it first, and they made sure to inherit the proper icons and like really look like it.
Yeah, I mean, for a Defender, the file size matches the legitimate Adobe or Google or whatever file they're making it trying to look like. If you parse the P header, like all the version information, everything else, all matches up. Same persistence mechanism, same service or description that they've now overwritten, or scheduled task like.
Right. And doing that is great, too, because now your persistence mechanism is 3 years old and legitimate. Yep. And so then you start looking through auto runs and you don't see anything interesting.
And then when you look at, like, if you're doing, like, service stacking at scale, let's say the service name's the same as persistence stacking at scale, it's all the same,
you
right?
negate out and ignore.
Yeah, same path, same persistence mechanism, all lines up. Yeah, and then with the double time stomping too, if you don't have access to those NTFS file name timestamps and you can't see that file name change timestamp, or you ignore it, like frankly most people do, it's not the most useful timestamp most of the time. You're not going to find that sort of thing when you're timelining through.
So there's only one timestamp that that they didn't modify when doing it, but we had no other way. Like, so the 3 of us were working on it, and we didn't have any way of figuring out what the hell was going on these couple systems, and we kind of were like, there's 10 other systems a day, like we're gonna look at these, but those ones kept bothering us for like, what exactly is going on here, and there was a couple indications that it was something. So I just wanted to categorize, like, we didn't know. Like, it's hard enough there's no artifacts to suggest that's how something's being persistent, but we never thought that an attacker would be bold enough to replace system binaries.
Yeah,
like, these guys were already replacing Adobe and stuff like that to hijack their persistence, but to actually replace like
Windows
binaries, the Windows error reporting,
Yep,
it was crazy. And no other indication that was the case outside of network stuff.
I guess if you place Windows error reporting and the system crashes, it doesn't really matter because the box still like.
True. Actually,
the box is crashed, right?
That could be a good TTP, right? Because like, there's certainly been lots of rumors that Microsoft finds some good stuff in those crash reports sometimes. So hey, now you're also kind of denying telemetry.
Yeah, absolutely.
So you mentioned hammer toss. I did want to hit on that. This was like the first case where I feel like steganography was a bit of a meme, and we've seen it. We've certainly since then seen more and more people using it, and people would kind of just do it as a little bit of a stunt. Hammer toss was kind of the first time I feel like combining that with legitimate services that blew me away.
Yeah, just downloading pictures off of Twitter or wherever, and it looks completely legitimate.
And so you mentioned Twitter, right? So what was it doing with Twitter? That was one of the first times that was the first time I saw. We've seen legitimate services before, but social media as a legit service for C2.
So they'd have like an API key set up to access Twitter as an account, and then they would then have that the account they were accessing like a friend of, but it would be like closed, or so that you like if you browse their account.
Yeah, so by controlling it at that API level and as that account for people that are trying to figure this out, it's a little bit different than just publicly blasting your commands, right? They would be protected tweets where other people couldn't view them unless
you
they
were
were friended.
friends.
So they use that access to kind of use that channel.
And then they were also generating usernames too. So like every day it'd be a different username. So they'd just pop up an account, post something, and then it'd get hit or it wouldn't. And then it'd redirect to like other secondary legitimate resources. So the tweet wasn't the thing, right? It was just a redirector to like where they were actually hosting the C2.
And the pseudo-random nature of APT29 at their peak, you know, the A team was what was crazy. Because I remember we were thinking like, they know what it's going to generate the next day. It's pseudo-random, so the next day they'll get on and register that account and set it up. And the same for the domain generation you mentioned. Like, they knew they owned all of these sites. They would actually just start using that next one the next day. So, pretty wild on those for sure.
Yeah, I mean, there's so much like the GSS bot, the Google spreadsheets.
Ooh, we've never talked about GSS bot.
Yeah, that's a good one. That's one that we saw them test, but never actually saw them deploy. So, you know, throughout this, we saw them test a bunch of different tools for like initial deployment. That's one of the ones that it seemed like they just decided not to use going forward. So we never actually saw them push that out.
I don't know why, because they embed, like, again, stuffing everything in WMI, right? They jammed the legit DLLs for access. It was what, 2 different DLLs needed to access. Yeah, to access the Google Spreadsheets. Yeah. And all of it was just, do you want to explain any more about GSS bot? And maybe we'll try to share some more about it.
Yeah, I mean, it basically uses the spreadsheets of C2, use WMI to do most of its storage. Overall, seemed like a good backdoor from my perspective, but apparently they
from
didn't
the
like
operator side, you would be typing commands basically into a spreadsheet cell and seeing the results in your other cell. Like, and the communication, again, we're doing that TLS fingerprinting. That communication, because it used the proper DLLs, like it just is looking like API access. So yeah, that was crazy. We had domain fronting. That was the first time I saw and was super confused by it. Some of that confusion remains today. Sorry. And we've seen people like kind of tamp that down. But what was going on with domain fronting?
Yeah, so they were using a Tor hidden service, and then that actually allowed them to use a plugin called Meek, which allowed them to do domain fronting. So they were doing it through Google at the time. Google has since really clamped down on that. So
this
Meek doesn't work with. Yeah, so this was meekreflect.appspot.com was the actual redirector. But it just looked like traffic to google.com, and then in the cloud it would get redirected around to where it needed to go. And then the hidden service, instead of being a redirector to like a web server port, it redirected to like the SMB and RDP ports, so that you could just like over Tor you could just RDP into these boxes, and it all just looked like traffic going to Google.
Yes, I mean, like, wrecking stuff at the time, it was so fun to find, and some of that stuff today still presents major challenges.
And we do have a blog post on that one.
Yes, so Dunwoody put out a bunch of blogs as follow-ups to this. So another cool thing, with a lot of these was, again, the use of legitimate services for both C2 and like data theft. I don't know if we previously talked about where they would store a lot of their email theft. They would store it on like OneDrive and mount it as a web dev share, or Google Drive, or in Gmail and stuff like that. So, I mean, again, 2014 they were leading the way with a lot of this stuff, and it still presents challenges today, and it's still a good technique today.
Yeah,
absolutely.
I'm trying to think, was there any other stuff we wanted to highlight that we hadn't talked previously about APT29? I know they were big on counter forensics as well.
Yeah, absolutely. You had a good one for that.
Yeah, I think if I remember correctly, they were aware of their forensic footprint, so they would say they'd log into a box with RDP. They would know that it would create like either create or update the registry key for that registry hive for that user. They would like delete their prefetch files for that, log out, log back in, say through like a Type 3 login, and then secure delete the registry hive.
Just from a mounted share.
Right, just from a mounted share. So you might see like logins, but all the other forensic artifacts like user assist keys and shell bags and recently opened documents all go away that we were hoping to rely on, and
Gone.
Yeah, next thing you know, they're gone. So that level of counter-forensics, like some groups do that, but that's, I'd say, probably the exception than the norm.
Agreed.
Yes. So I guess the theme is we were a little bit worried when we heard people talk about the 2018 activity, the November 2018 activity, and saying, like, really, these guys are using Cobalt Strike? And hopefully by our blog you saw that wasn't completely the case. There was a lot of deception at play. But this is what they were capable of in 2014. And
I wonder what they're capable of now.
Yeah. So if you know, definitely reach out. We're always on the look for them and for their activity. So thanks, Dunwoody, for coming on. And actually, I think we have a quick surprise guest to add a little bit more context maybe onto what was going on in 2014. Welcome.
Cheers.
Cheers.
Out of beer.
Thank you for having me on.
Alex Orleans, welcome to the show. Wanted to talk a little bit about what you think was maybe going on in 2014. So Alex is with our eyesight intelligence team and is a bit of an expert in critical infrastructure attacks, but also one of our resident Russian espionage experts.
Yep. So I mean, to kind of zoom out, you have to go back actually all the way to 2013 to kind of get a good idea for what happened probably in 2018. So 2013, you saw things starting to spin up in Ukraine. I know that the breach, for no easy breach, a lot of Ukrainian information related stuff was kind of interest to 29. You had the Maidan events beginning in the fall and the winter. You had the revolution.
And that was a theme for a lot of the 2014 compromises.
2014, 15,
Dunwoody is modest and worked a bunch in the 2014, 2015 arena, and a lot of that was focused on Ukrainian information.
So, like an example would be, we'd be doing a response at a U.S. university, right? And the 29 would be stealing email, and when you figured out, like, oh, it's this professor, you'd go Google and be like, oh, they're a professor of, like, Ukrainian studies or Eastern European, like, something Ukrainian or Eastern European or something. And this wasn't just at, like, one university. This was, like 5, 6, 8, 10 universities that we did instant response investigations at. So, there's only one country in the world, or especially at the time geopolitically, where that would really be.
Certainly, all the data that we watched as it went out the door was all related, multiple places. So, no, good context. By the way, they also stayed where they could at those universities because they love using that for their massive email campaigns. But
there you go.
Back to the Ukrainian focus.
So you had the Ukrainian focus. Then what was driving that was leading up into the Maidan revolution in February of 2014. You had a lot of interesting debate within the Russian intelligence community about what was going to happen. And it ended up that, one service, the Foreign Intelligence Service, the SVR, kind of got blamed for not predicting the success of the revolution. And then you saw the Federal Security Service, FSB, which is more domestic focused in Russia, and GRU, the Russian military intelligence wing, focusing on trying to take over operations there. But what you saw for all of 2014 and kind of into 2015 as things developed and continued in Western Ukraine with the armed conflict was a sustained Russian intelligence priority related to Ukrainian affairs that might not have really been there so much beforehand. So you talk about the A-team coming out. If you're having A-team capability, bringing them out during that time period makes a lot of sense because it's going to be of leadership interest. It's going to be of organizational interest for you to be able to deliver that no matter what agency you're affiliated with.
So from our end, what we were trying to figure out, perhaps what's an explanation for I'm sure they didn't expect to burn that many backdoors or for us to come out and speak about so many of them or catch them in testing. But the reason maybe to throw everything at it and maintain it is to go for sort of the lead position in providing that particular intelligence to meet that requirement.
Yeah, absolutely. And even that could even be a bigger incentive depending on if they're sponsored by a particular Russian service. It could even mean that there are political or organizational dynamics saying we really need to deliver on this compared to so-and-so. So
we're willing to throw whatever resources it takes to make that a reality.
Because within that competition space, we talk about within the West, there's competition between intelligence agencies, but they're not burning each other's officers and assets and stuff in like what's going on over there. So the resource competition is much more fierce. So being willing to throw more resources to meet those requirements and be seen delivering is a lot higher. And then you have, you look at their activity, we're trying to put the 2018 into context, right? You then see them going after their traditional political intelligence kind of spectrum of targets between...
Certainly the 2016 timeframe.
And 2015 too. And then they kind of drop off the map after their big, the U.S. election happens, they do another one of their big kind of collection efforts, and then they just drop off the map. And then we see, something that looks like APT29 come back right after the midterms. There's a lot of possible explanations there. One of them could be, that these operators really have a political intelligence collection requirement, and they couldn't not engage in that kind of louder activity. They needed to do something to at least ensure some minimum level of coverage, or maybe it was something even pro forma. And then you get into something more complicated where it could have been, and you mentioned that there was deception in the tactics being used, there could have been deception in the intent as well. It could have been masking particular intent going after a certain target that remains unknown to researchers. It could have been
like getting lost in the noise.
Which would fit within 29's general standard practices of using noise as cover for action.
And that may fit even with, like, if you saw on Twitter, I talked about like kind of the number of organizations in the 2018 Spearfish, but like the number of emails that went to them, there was like a really like weird distribution where it was like most of them it was 2 or 3 people, and then a couple that was like 100 or 200, pretty high numbers of individuals. So that might, I guess the idea there is you just create so much activity that either defenders, either from a national or individual level, just can't keep up with it. Or,
But then there's also the fact that, because of this was so loud, and I think you and I have actually interacted a little bit on Twitter about this.
What?
The idea that, for basically 48 hours, there was a long stretch where the security community was like, look, they're back and we caught them. And that's a dynamic that, bad guys can count on if they can predict that behavior for incident responders and researchers.
If it were any other group, I wouldn't think that was the case. But as we're talking with Dunwoody, they have APT29 has a very solid understanding of the defender mindset, forensics, how the process works. So I would expect they have a very solid understanding of the threat intel community. And while I like to keep it fact-based, the facts were that we saw organizations that were targeted that were much more focused on threat intel sharing throughout it and attribution throughout it than what actually happened post-compromise, and immediate moving to throughout their network, which did happen.
Yeah. So again, the noise really stood out to me about the 2018 activity. Right. There's still wiggle room on if it was APT29 or not. I think there's a debate to be had there. I'm not sure how much of a debate, but a worthwhile one to whatever extent. But yeah, I think that,
Yeah, despite it being listed in the DNC complaint, at this point, at the point of this recording, we still track that as separate activity that's probably related, but we haven't tied it together yet, if we ever will. So, yeah.
Awesome. Well, thanks for your input and insights into that. I love kind of thinking about like what this has meant, and we've been able to leverage like their techniques and what they've done to kind of drive our investigative methods, features we've put into our products. Like they've really been kind of an inspiration for us almost in terms of how we get better every day. So appreciate your time.
Sure, thank you.
Cheers.
Very glad to be here.
Catch you next time on Say the Hack. Thanks.